MS Ramaiah University of Applied Sciences.
Hi students, let us discuss the design of a digital circuit for specific functionality. Aim of the experiment is to simplify the given expression and to realize it using basic gates and universal gates. The canonical form of the given expression is shown here. Canonical forms, that is normal forms, implies that any Boolean function can be written in disjunctive normal form, that is sum of min terms, or conjunctive normal form, that is product of max terms. A Boolean function can be represented by a Karnaugh map, that is K map, in which each cell corresponds to a min term. The cells are arranged in such a way that any two immediately adjacent cells correspond to two min terms of distance 1. There is more than one way to construct a map with this property. The truth table and K maps for the given expression are shown here. The reduced functionality expression for the given expression y can be realized using basic gates as shown here. It should be observed that two possibilities exist for implementing the obtained expression of y. The functionality of expression y can be obtained only using NAND gates as shown here. The functionality of expression y can be obtained only using NOR gates as shown here. The apparatus required for this experiment are trainer kit, connecting probes ICs 7408, 7400, 7402 and 7432. Procedure for implementation of reduced expression. Implementation using logic gates. First, realize the simplified expression using logic gates. Second, connect VCC and ground as shown in the pin diagram. Next, make connections as per the logic gate diagram. Apply the different combinations of input according to the truth tables. Check the output readings for the given circuits. Check them against the truth tables. Verify that the results are correct. Implementation using universal gates. Convert the AND OR logic into NAND NAND and NOR NOR logic. Implement the simplified Boolean expressions using only NAND gates and then using only NOR gates. Connect the circuits according to the circuit diagrams. Apply inputs according to the truth table and verify the results. Conclusion. The digital circuit for a specific functionality is realized.
Hi students, name of the experiment is to design a digital circuit for specific functionality, and aim is to simplify the given Boolean function and verify it using basic gates and universal gates. The apparatus required for this experiment is digital trainer kit. This is a digital IC trainer kit which we are using to perform the experiment. In this particular kit, you can see the pins at the top. Here the black color pins represents the input, where you can connect the input pins. There are 10 black color pins, so there are 10 inputs, and these inputs can be controlled using this toggle switch which are there at the bottom of the input pins. Whenever the toggle pin is at the bottom position, it represents the input is logic low, and if we keep this toggle switch at the top position, which represents the input is logic high. So now at the same time, you can see there are 10 output pins which are there in the red colors, and you can connect the output pins to this red knobs, and the output can be seen through the LED pins, LED bulbs which are provided at the top of the output pins. And also you can see there are 4 IC bases, 1, 2, 3, 4, which is used to place an IC, and in each IC base it consists of 16 slots, 8 slots at the left and remaining 8 slots at the right, and each IC base is equipped with VCC and ground in order to power up the IC, and the IC is going to placed in each IC base, and these knobs you can see at the left and right side of the IC base are used to connect the IC pins. pin number 1 represents the slot number 1, pin number 2 represents the slot number 2, and it will continue in the same way. And these two are used to check the connectivity of the patch card. So if you want to check whether the patch card is working properly or not, we have to place the patch card between these two knobs. If red color bulb glows here, that means the patch card is working properly. Patch cards, these are the patch cards which we are using to connect the circuit. Basic gates, so these two are the basic gates which we use to realize the given function, and this represents 7432 and this represents 7408, and universal gates. So these are the universal gates which are used in this experiment. One is NAND gate and another is NOR gate, 7400 and 7402. The given Boolean function can be minimized using K-map, and we will get two forms, SOP form and POS form. We are going to realize both the expressions in this experiment. So before connecting the circuit, let us check the conductivity of the patch cards. In order to do that, first switch on the power supply to the trainer kit, then take the patch cards and connect the patch cards in conductivity tester. So I am turning on the power supply to the digital IC trainer kit. Now we will check the conductivity of each patch card. Take the patch card and connect between the conductivity tester, and you can see a LED bulb is on, and also we are getting a beep noise. So that means this patch card is working properly. Similarly, I am doing the conductivity test for another patch card. So this says this patch card is working fine. Similarly, you can test all the remaining patch cards. After checking the conductivity of the patch cards, let us place the ICs into the IC base. So I will take 7408 IC, which represents AND gate, and I am going to place this IC into the IC base. Before placing this IC into the IC base, make sure the notch of the IC should be directed upwards, and you have to place this in the IC base and close the lever. Similarly, I will take one more IC, that is 7432, which represents OR gate. Make sure while placing this IC into the IC base, the notch of this IC should be directed upward direction. So then I am going to place this in the second IC base and close the lever. Now based on the circuit diagram, let us do the circuit connections. Before starting the connections, make sure VCC and ground for each IC base is connected. So I am connecting VCC and ground for first IC. Pin number 8 and pin number 9 are not used since it is a 14 pin IC. Similarly, I am connecting for second IC base. Here also pin number 8 and 9 are free since it is a 14 pin IC. Now as per the circuit diagram, I am connecting. So pin number 1 of AND gate is considered as input, that is C. Here pin number 2 and 4 are shorted, and from that it is given as a input B. I am considering this as B and this is C. And pin number 5 of the AND gate I am considering as input D. I am connecting to the input knob. So now the output of the AND gate is connected to input of the OR gate, that is pin number 1. An output of one more AND gate, that is pin number 6, is connected as input of the OR gate, that is pin number 2, and output of OR gate, that is pin number 3, is connected as a output. I am connecting it in the output knobs. So this completes the circuit connection. So we will turn on the power supply to the digital IC trainer kit. Then now we will verify the outputs according to the truth table. There are 3 inputs, B, C, D and 1 output. So now by changing the inputs we will see the output. So now according to the truth table, whenever the inputs are 0 0 0, output will be 0, and for the second combination inputs are 0 0 1 and output will be 0, and for the next combination input is 0 1 0, still output will be 0. The third combination input is 0 1 1, output will be 0. Next I will make input as 1 0 0, for that output is 0, and next combination is input is 1 0 1, for that the output is 1. So that means it is true according to the truth table, and we will go for the next combination, that is 1 1 0, for that also output is 1, and we will go to the last combination, that is 1 1 1. So the output is high. So therefore it is true according to the truth table. So this completes the SOP realization using basic gates. So we have completed the realization of the SOP expression. Now let us realize the POS expression using basic gates. Now these are the two same basic gates we are using for this experiment. Now I am placing this ICs into the IC base. This is 7408 IC, and make sure again while placing this IC into the IC base, the notch of the IC should be directed upwards. I am placing this into the IC base. This is 7408, and I am taking 7432. Again care should be taken while placing the IC, notch should be directed upwards. I am placing it in the second IC base. Now let us do the connections. First I will connect VCC and ground for each IC base. Pin number 16 represents VCC and pin number 7 represents ground. Similarly for the second IC base, now as per the circuit diagram we will connect the circuit. So pin number 1 of 7408 IC is considered as B input. Pin number 1 of OR gate is considered as C input. Pin number 2 of OR gate is considered as D input. I am connecting to the input knob. Pin number 3 of OR gate is connected as input of the AND gate, that is pin number 2, and finally pin number 3 of the AND gate is connected as the output. So I am connecting this to the output knob. So this completes the connections of the circuit. Now we will turn on the power supply to the digital IC trainer kit. So LED bulb is on, so that means it is powered up. Now based on the truth table given, we will verify the logic circuit. So there are 3 inputs, B, C and D, and 1 output. Now I will try to change the input combination. Whenever the inputs are 0 0 0, the output will be 0, and I will try to change the input combination 0 0 1, the output will be 0, 0 1 0, the output will be 0, 0 1 1, the output will be 0. Then I will make 1 0 0, the output will be 0. Then I will make 1 0 1. You can see the output is 1, therefore it is true according to the truth table. I will try to change the inputs. 1 1 0, you can see the output is high, and also for the last input combination 1 1 1, the output will be high. So this completes the realization of the given POS form using basic gates. Now let us realize the same SOP function using universal gate. I am using NAND gate in order to realize the given SOP expression. So these are the NAND gates, 2 NAND gates I am using for this experiment. These are the NAND gates, that is 7400 ICs, which we are using for this experiment. Now we will place the ICs into the IC base. This is 7400 IC. So while placing the IC into the IC base, again make sure the notch should be directed upwards, and I am placing it into the first IC base and close the lever. Similarly I will take the one more IC, I am going to place it in the second IC base. Now let us do the circuit diagram as per the logic circuit. First I will connect VCC and ground for each IC base. Pin number 16 represents VCC and pin number 7 represents ground. Similarly, I will connect for second IC base. Pin number 16 is VCC, pin number 7 is ground. Now as per the circuit diagram, pin number 1 of the NAND gate is connected to the input C, so therefore I am connecting to the input knob. Pin number 2 and pin number 4 of the NAND gates are shorted, and from that it is connected to an input, that is B input. Pin number 5 of the NAND gate is considered as one more input, that is D input. So we have connected 3 inputs. Pin number 3 of NAND gate is connected to pin number 9. So if this is 7, 8, this is pin number 8 and this is pin number 9. So therefore I am connecting to the pin number 9. And pin number 6 of the NAND gate is connected to pin number 10. So 12 represents pin number 10. And output, that is pin number 8 of the NAND gate, is connected to output. I am connecting in the output now. This completes the connections for SOP using NAND gates. Now we will turn on the power supply to the digital IC trainer kit, and you can see the LED bulb is on, therefore the kit is powered up. Now we will verify the given truth table. So for the input combinations 0 0 0, that is B C D, this represents B, this represents C and this represents Z. For the input combination 0 0 0, you can see output is low. So for the input combination 0 0 1, the output will be 0. For the next combination 0 1 0, the output will be low. For the next combination 0 1 1, the output will be 0. Similarly, for the next combination 1 0 0, the output is 0. Similarly, for the input combination 1 0 1, the output is 1. So now I will change the input combination to 1 1 0, the output is high. So now for the last combination, for 1 1 1, the output is high. So therefore we have verified it and it is true according to the truth table. So this completes the SOP realization of the universal gate, that is NAND gate. We have completed the SOP expression using NAND gate. Now we will realize the POS expression using the same NAND gates. We require 2 NAND gates. Now let us start the connections as per the logic circuit. Now we will turn on the power supply to the digital IC trainer kit. You can see LED bulb is on here, so therefore it has been powered up. Now we will do the connection as per the logic diagram. So before doing that, let me connect a VCC and ground for every IC base. So pin number 7 of this represents ground. Similarly, pin number 16 of this represents VCC and pin number 7 represents ground. Now pin number 12 of IC is connected as B input. So this represents 7, 8, 9, 10, 11, 12. So therefore pin number 12 represents the input, that is B input. I am connecting it to the input knob. Pin number 1 and 2 are shorted, and from that one common I have taken. This represents one more input, that is C, therefore I am connecting it here. Pin number 4 and 5 are shorted, and one common is connected as an input, that is a D input. Now pin number 3 of the IC is connected to pin number 9, so that is nothing but pin number 11 here. This is pin number 9, and pin number 6 of the IC is connected to pin number 10. This is here. Now pin number 11 of this IC is connected to 1 or 2 of the second IC. Therefore I am shorting 1 and 2. I am connecting here. Pin number 13 of this IC is connected to pin number 8 as per the logic circuit. So now last, pin number 3 of the second IC, this is the output, so therefore I am connecting this pin to output knob. So now this completes the connections for POS expression using NAND gate. Now we will check the outputs according to the truth table. So we have 3 inputs, B, C and D, 1 output. Now I will change the input combination. For the input combination 0 0 0, the output will be 0, that you can see through this LED. LED is off. For the input combination 0 0 1, the output will be 0. For the next combination 0 1 0, 0 1 0, the output will be 0. For the next combination 0 1 1, the output will be 0. And for the next combination 1 0 0, the output will be 0. For the next combination 0 1 0 1, you can see the output will be high. And for the next combination 1 1 0, the output will be high. And for the last combination 1 1 1, the output will be high. So therefore we have got a correct outputs according to the truth table. The SOP and POS expressions can be realized using NOR gate in a similar way. So therefore this completes the experiment.
At MSR UAS, we spark your imagination unlike any other.